Welcome back, students. This lesson is of class 10th for the subject of mathematics, topic chapter 7, ratio and proportion, and is being submitted to you on 5th July 2021. Students, in the previous video, we have discussed about ratio. Now let's move on to another topic, that is proportion. So now children, let us discuss what is a proportion. Actually, it is an equality of two ratios, and if two ratios are equal, they are said to be in proportion. So I repeat, an equality of two ratio is called a proportion. So now children, let's take four terms, and your four terms are A, B, C, D, and they are said to be in proportion if and only if A ratio B is equal to C ratio D. Means the first ratio is equal to the second ratio. Is it clear, children? And moreover, this A and D are called extremes, and the B and C are called means. Okay, children? So it means if four quantities are in proportion, then the product of means, that is, can you tell me what is the product of means? That is B into C, and the product of extremes, that is A into T, are always equal. So children, we can say that AD is always equal to BC. Is it clear, children? Because if four quantities are in proportion, their ratios are always equal. Okay, now let's move on to the very important one, that is continuate proportion. Let's see what is your continuate proportion. Now, children, whenever the quantities, suppose you have more quantities like A, B, C, D, E, F, and so on, they're said to be in continuate proportion if you have A upon B, that the ratio of A and B is equal to B upon C, then C upon D is equal to D upon E, and so on. So they are said to be in continuate proportion. Is it clear, children? Are you clear with this? What is continuate proportion? Continuate proportion means if the quantities are in proportion, they are in continuate proportion, then it will be A upon B equal to B upon C, which is equal to C upon D, and so on. Now, children, if we take only three terms, then your three terms are said to be in continuate proportion when your A upon B is equal to B upon C. Okay, three terms are said to be in continuate proportion when A upon B is equal to B upon C. Okay, children, this is a very basic result of continuate three terms in the continuate proportion. So now, children, in this A, B, C, your A is called the first term. This is called the first proportional. C is called the third proportional, and B is called the mean proportion. I repeat, if three terms, that is A, B, C, are in continuate proportion, then your A upon B is equal to B upon C. Okay, and further, if you cross multiply, children, you will get a very important result, that is B square is equal to AC. Okay, so we have a special name. This is called the first proportional. This is called the mean proportion, and this is called the third proportional. Is it clear, children? And further, you can say that B square is equal to AC. Or further, you can write B is equal to under root AC. Hence, you can say that B is the mean proportion between two numbers. Okay, so let's try the questions based on this explanation. Your first one is exercise 7B, question number 2. Let's discuss that one. Now, children, here you have to find the fourth proportional. Okay, so now, children, let's see what is given to us here. The first is this one, second is given to you, third is given to you, and you have to find the fourth. Let's take that as x. Okay, so now you know that if four terms are in proportion, then the product of extreme is equal to product of means. Okay, so you know that your extremes are a square minus ab plus b square and x. And your means are a cube plus b cube and a minus b. Okay, so now children, let's apply the formula. Your formula will become a square minus ab plus b square multiply x is equal to a cube plus b cube multiply a minus b. Now, when you shift a square minus ab plus b square on the other side, it will divide. Okay, and children, we know the formula of a cube plus b cube, and that is a plus b times a square minus ab plus b square. Okay, and already we are multiplying it with a minus b and divided by a square minus ab plus b square. So now children, when you cancel it, you will just get your a plus b into a minus b, that is a square minus b square. Okay children, I hope you are clear with this question. Now let's move on to the another question, that is question number 4. So your question number 4 is you have to find the the mean proportion between root 26 minus root 17 and root 26 plus root 17. Now let's find out the mean proportion between these two. So children, I told you the mean proportion is actually the square root of the first proportion multiplied with the third proportion. So now let's see what you will get it here. So your mean proportion will be square root of root 26 minus root 17 multiplied by root 26 plus root 17. Okay, children. So here you will get a formula that is a minus b multiply a plus b. Okay, so that formula is a square minus b square. So actually you will get root 26 square minus root 17 square. So you will get under root 26 minus 17, that is square root 9, and square root 9 is 3. So I hope children you are clear with this question. In this you just have to find the mean proportion. Okay children, now let's move on to our another question, that is question number 7. So now children, in this let's read the question very carefully. What least number must be added to each of the numbers 6, 15, 20, and 43 so that the resulting numbers are proportional? Okay, so it means they are asking what should be added to all the numbers so that they become proportional. So let's take that as x. So now it means 6 plus x, 15 plus x, 20 plus x, and 43 plus x will be in proportion. So you know that in proportion, the product of extreme, that is 6 plus x times 43 plus x, will be equal to the product of means. And here your means is 15 plus x times 20 plus x. Okay, children? So now just solve it. And after simplification, you will get 14x is equal to 42. And finally, the value of x as 3. So now, children, you can say that 3 should be added to all the numbers so that your number becomes proportional. Okay. Now, children, let's discuss very important method, that is K method. Now, children, you can use K method to solve the proportion. It will make our calculation easier. Now, in this, you are given with A ratio B is in proportion to C ratio D. Show that A plus C whole cube upon B plus D whole cube will be equal to A upon B times A minus C whole square times B minus D whole square. So now children, according to K method, whatever ratio is given, you will take that as K. Okay, so it means A upon B is equal to K, C upon D is equal to K. So it means the value of A, if you compare A upon B and K, A will be equal to BK and C will be equal to DK. Okay, children. So these two values are there. Now you just have to take the left hand side, substitute the value of A and C there, and after cancellation, you will get your answer. So now let's see what we have done here. Now your left hand side is A plus C whole cube upon B plus D whole cube. Okay, so after substituting and after cancellation, your answer is K cube. It will be K cube times B plus D whole cube upon B plus D whole cube. And when you cancel it, you will get your answer as K cube. Okay, this is your left hand side. Now let's solve right hand side. And after right hand side, your value is A times A minus C whole square whole upon B times B minus D whole square. So now children, when you substitute the value of A and C, okay, instead of A, you will put BK. Instead of C, you will put DK. Okay, so now let's substitute the value and take out the common, and finally you will get K cube. So children, you can see that your left hand side is equal to right hand side. Okay, so it means you can say that your both the values are equal. Is it clear, children? Now let us try question number 17. Now, children, in this question number 17, you are given with A, B, C are in continuate proportion. Prove that A square, B square, C square multiply A power minus 3 plus power minus 3 plus C minus 3 is equal to A cube plus B cube plus C cube. So now children, let's try this question with the help of K method. So children, A, B, C are in continuate proportion. So you know that A upon B is equal to B upon C, which is further equal to K. Now children, let's compare the last two. You will get B as CK, C times K. Okay, and now let's compare the first and the last one. You will get A is equal to BK, and you already know the value of BK. If you put it here, it will become CK square. Okay, so now children, according to this question, the value of A is CK square and the value of B is CK. So now let's take our left hand side. Wherever in the left hand side we will find A and C, A and B, we will substitute the value. So let's see, it's just substitute the value here. Instead of A, you will put CK square. Instead of B, you will put CK, and C is already C. So just substitute. And children, when you substitute, when you take out common, and after taking common, your value is C cube times 1 plus K cube plus K6. Okay, children. So this is your left hand side. Now let's talk about the right hand side. In right hand side, it is A cube plus B cube plus C cube. Okay, so now let's substitute the value of A and B in the on the right hand side. So when you substitute, you will get as C cube, K cube plus C cube, K3 plus C3. So now children, take out C3 common, you will get K6 plus K3 plus 1. So now children, you can just check out your left hand side and right hand side is exactly same. Okay, so it means both the quantities are equal. Okay, now let's move on. Another thing, now children, we have very important result. Now if you have equal ratios, now you can see in this, you have A upon B, which is equal to C upon D, which is equal to E upon F. So now children, then this all the ratios is equal to sum of all the antecedent and sum of all the consequent. Okay, children, what is it? All the ratios will be equal to sum of antecedents divided by sum of consequents. Okay, so you can say that A upon B, C upon D, E upon F is equal to A plus C plus E divided by B plus D plus F. Okay, children, let's take an example here. It's given that 1 upon 3 is equal to 2 upon 6 is equal to 7 upon 21. So now children, I told you according to the result, each ratio will be equal to sum of antecedent, that is 1 plus 2 plus 7, divided by sum of consequent. It means 3 plus 6 plus 21. Okay, so when you add it, you will get 10 upon 30. Okay, so all the ratios are equal. Okay, now let's do this question number 2. This is again very easy. We have to use the above result in this. Now children, here, if x upon b plus c minus a is equal to y upon c plus a minus b is equal to z upon a plus b minus c, then prove that each ratio is equal to x plus y plus z whole upon a plus b plus c. Now children, right now I told you, now if the ratios are equal, then each ratio is equal to sum of the antecedent, that is x plus y plus z, divided by sum of consequence. That is, first is b plus c minus a, the next is c plus a minus b, and the last one is a plus b minus c. Okay, so now children, let's cancel whatever you have. So you are just left with a plus b plus c. So your final answer in this is x, each ratio is equal to x plus y plus z whole upon a plus b plus c. Now children, I guess you are clear with the chapter. Now please try these sums in your registers. Exercise 7a and 7b. Thank you, students.